A very good evening to everyone. This project presentation is based on Microwave Oven Simulator project using PixSimLab and MPLab XID for the internship with the Emertxe Information Technology presented by Atul Kumar Srivastava, BTech Electronics and Communication Engineering 4th year student from the Institute of Engineering and Technology Dr. Ram Manohar Lohia, Awadh University, Ayodhya. The contents of the internship are topics learned during the internship required for the project, what is microwave oven, requirements, microcontroller and microprocessors, PixSim Lab, CLCD, matrix keypad commonly known as MKP, ISR, interrupt service routine, which is the main or the most, you can say, topic for the project, timers, project implementation, etc. Topics learned during the internship: general description, MPLab XID, XE8 compiler, PixSimLab, introduction to various peripherals of PIC16 F877A, attended multiple quiz also. C programming. C programming is used in system software development, embedded system development, OS, kernel development, and much more. C is used in various specific domains and it is for free formatted language and efficiently and portability. Data portability, integrated number positive or negative number systems, data types integral. Conditional constructs in C are single iterations, that is if, else if, and switch case. Multiple operator iterations are while, do while, for. Unconditional are continue and break. Operators. Operators are the symbols that are used to perform mathematical or logical operations. Arithmetic operators, relational operator, logical operator, assignment operator, increment or decrement operator, conditional operator, bitwise operator, spatial operator, etc. Array, collection of data of same type. Pointers, variable which stores address of the another variable. Functions, self-contained block of statement can be executed repeatedly are called functions. Microcontroller. Microcontroller is the basic and the innermost part of this project. Without microcontroller, you cannot make even one project or microprocessor. Microcontroller is a compact integrated circuit designed to govern a specific operation in embedded systems. A typical microcontroller includes a processor, memory, and input-output peripherals on a single chip. Microcontroller has a processor along with the internal memory and input-output components. You can use it in compact systems. Cost of entire system is also low. As external components are low, power consumption is also low. Microprocessors. Microprocessor is the heart of the computer system or the CPU. Or you can say microprocessor is the CPU. It is the only processor, so input, memory, output components need to be connected externally. Circuit becomes large and cost is high. Cannot be used in compact systems. Due to external components, total power consumption is high. Embedded systems. Embedded system is a combination of computer software and hardware, which is either fixed in captive capability or programmable. An embedded system can be either an independent system or it can be a part of large system. Categories: standalone, real-time. Network challenge in embedded system is input-output, embedding an OS. OS means operating system, code optimization, etc. Real-time aspects: hard real-time should meet its deadline. Firm real-time, similar to hard real-time, information delivered after deadline is invalid. Soft real-time can have tolerance in meeting its deadline. Means suppose you are doing a work and it is given that this work you have to do in this supposed time, that and if you did not do that work in that time, then it's not meet the deadline, so that is soft real-time. Means not meet the deadline but your work is also, means you can say that your work is absolutely programmable or anything else. So it's a soft real-time system. Software required: MPLab XID, PixSimLab Simulator, XE8 compiler. These are the software required for this project. Interfaces LED introduction. Simplest device used in most of the embedded system application as feedback works just like diode. Low energy consumption, longer life, smaller size, faster switching make it usable in wide applications. field like home, lighting, remote control, surveillance, and many more. LED basic program demo. Basic LED program toggling LED connect to ports. Build hex file in MPLabXID software, then in PIC software. Load hex file in board, that is PIC16F877A, PIC Genius board. Microcontroller PIC16F877A. These are the codes for the LED toggling. CLCD, character liquid crystal display. It has two types of display, that is 16x2 and 16x4. 16x2 means there are 2 rows of 16 columns. 16x4 means there are 4 rows of 16 columns. This is used to display all the ASCII characters. ASCII characters means American Standard Code for Information Interchange, and symbol. It has totally 16 interfacing lines from D0 to D7 data lines. It has built-in controller. It has own ROM and RAM. This is the table for the 16 characters that CLCD. First one is for VDD, second one is for VDD, third one is for V0, that is voltage, fourth one is for register select, fifth one is for read or write, sixth one is for enable, seventh one is for D0. Data lines from D0 to D7. These are the from 7 to 14, that is data lines from D0 to D7. Then 15 is acknowledgement and K is enabled. RS line is the register select line. RS value is O, that is instruction. RS value is 1 for data. If RS value is register select value is 0, then it is the microcontroller is providing the instruction. How we can know that this CLCD we are providing any data and see that CLCD act as a instruction or data? So if register select value is 0, then the CLCD understand it as a instruction. If register select value is 1, then CLCD understand it as a data. Data processed, two methods are there for data processing, that is delay method and poll D7 method. In poll D7 method, we want to continuously monitor D7. Means for that poll D7 in poll method, for that we want to continuously monitor, matlab we have to monitor that D7 pin every time. The D7 pin is 14, at the 14 lines it is D7 pin. That you can see here in 14 lines it is, this is D7 pin. So for if data is read, so a read or write value is 1. If data is written, means data is given and data is already written, then it is 0. For reading data, the value should be 1. For writing data, the value should be 0. In read or write pin is permanently grounded. That means only write a data. In CLCD, from D0 to D7 are connected to port D, and our register select as RS and enable pin are connected to port E. 8-bit data D0 to D7, 4-bit data D4 to D7. For 8-bit there are two types of data, that is 8-bit and 4-bit. For 8-bit data, the data lines are D0 to D7, and for 4-bit data lines are D4 to D7. These are data lines for 8-bit and 4-bit. Enable pin act as indicator by appraising LCD about the inception data transmission by microcontroller. Tactile switches. In matrix keypad, we need to configure rows and output and columns as input. As you understand that in matrix keypad, we need to configure rows as output and columns as input. When designing pull down interface, R1 is 10 times greater than R2. Triggering methods. Level triggered. It is always generates an interrupt when the level source is triggered. As triggered, it generates interrupt module when it detects an asserting edge of interrupt source. Bouncing effect. There is a metal plate and terminal suppress pulse detection while pressing the tactile switch. Matrix keypad. 4x4 matrix keypad are commonly used in embedded applications. Such keypads are seen in telephones and other commonly seen applications. And here we use PIC where we use the microcontroller board PIC16F877A, where these matrix keypad we can see. The keypads are column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8. That pin name are there. The advantage of matrix keypad is that The use of it will allow the programmer to reduce the number of pins to be used. Means by using this we can reduce the number of pins by programming for programming for each and one specific key to given instruction. In 4x4 matrix keypad, there are 4 rows and 4 columns connected with 16 push down button switches. Timers. It has 3 modes like PWM, pulse width modulation or pulse generator. Counter, PW or PP measurement. Tick, up count or down count. Quantum, system clock setting, scaling, pre or post. Resolution, register width. The micro mode and grill mode are under optional mode. The timer is set with matrix keypad start to clear and hash to enter. The toggle LED 8-bit resolution is required. So that's all. Now we are going to move to the programming part and the MPLabX ID and the controller PIC16F877A.
Start page. It was founded by Microchip, and we are going to do the coding for microwave oven simulator. So these are the sections under it. In the header files, I have declared clcd.h, main.h, matrix keypad header files and timers header files in it. And the source file, we have the main.c function, isr.c, clcd.c, matrix keypad.c and timers.c. So let's go on to the main.c. This is the code which was written for the microwave oven simulator. In this code, we are calling all the other .c files into this main.c. Example timers, matrix keypad.c files is called into the main.c file. So inside this main, we have defined all those macros from the header files, such as clcd.h header file. It has many macros in it. We have defined there and we have called it to the main file. So as matrix keypad.h, timers.h, we have defined for example in matrix keypad we have defined row 1 as rd3, row 2 as rd2 and so on. So we have defined even high as 1 and low as 0 for user understanding. Now let's move on to the main.c file. So after those declaration, we have called all the and defined all the functions related to our 4 different types of mode. So we are just calling all the mode. First we are calling the cooking mode display, where we are calling the cooking mode display function. Micro mode we are calling, and grill mode, convection mode, everything we are displaying in the output. So to start with, we are going with the power on screen, where we indicate microwave powering on microwave oven, and we then move on to the micro cooking mode displays, like example micro grill convection start. We are setting the time for those operations, and the set time function is also we have declared. And we do even check for door status, even if the door is opened or not, we do check for it. So we are defining that too. Time display screen, where the timer is decrementing in the output, so those functions are also defined in here. And set temperature screen, so we are using the set temperature function in the set temperature screen in the convection mode. So for that we are said this is the function related to the set temperature. We are defining this much functions. And now let's move on to the clcd.c file. It gives the initializations of all the CLCD peripherals. Put character, how to print a character in the CLCD. CLCD print gives the how to print the string in the CLCD, and display, how to display the CLCD. So everything in this initialization is done. So isr.c file is also being done, which generates an interrupt for the timer to run. And the matrix keypad initialization such that if column 1 is equal to low, return 1 will be returned. If key 2 is pressed, key 2 will be returned, and so on. So matrix keypad initialization is also being done here. And timers.c file, In this file we are using the timer 2 for our operation, so timer 2 initialization is also being done here. So all together we are calling it in the main function, which gives a final microwave oven simulator project. So hence this is all about MPLAB XID, and if I build is successful, time taken is 207 milliseconds, and we need that hex file to be loaded into the board. So for that hex file, the path is microwave oven simulator.x distant default production microwave oven simulator.x. So this is the hex file we are going to be needed for the final project. Hence the code is built successfully, and hence this is the code for our microwave oven simulator project. As you can see, this is the Pixim Lab board right here, PicGenius board. So in this board you can see all the 7-segment displays are available. All those tactile switches which we have seen in those PPTs are available, matrix keypad switches, and you can even see the fan right here. The LEDs are also, the LED arrays are also available from D0 to D7. The LEDs are connected to port D and as well as to port B. So you can see these switches over here. It is used to if we shift this switch to this side, you will get those LCD display screen. So switch to the other side, it will turn to off. Now we'll switch to this LCD screen because we need those LCD to be written in the program. Now let's load our hex file which we have obtained from the XC8 compiler. Now the hex file is loaded. As you can see, the first screen is the power on screen, microwave oven. It will be displayed and you will go into the cooking mode display. So this is the cooking mode display screen, and in this screen we have the 4 modes of cooking, like micro mode, grill mode, convection mode and the start mode. So now let's press the key 1. Let's go on to the micro mode. So the power equal to 900 watts, those screen will be displayed as we saw in the PPT, and now the set time screen will appear. So this is the screen where we need to set time, minutes and seconds. Now let's set those minutes. So I will set 32 seconds and 1 minute time for the micro mode to appear. Now I will press, if you want to clear those values, you can clear by pressing star. So you can see the before it was 1 minute, now it has become 0 minute and 32 seconds. So I will clear those 32 seconds. For now we will put 20 seconds to check the output. Now I will set the time in the micro mode. Now I will press the hash key to enter into the time display screen. So this is the time display screen. You can see those timer is decrementing to 15, 14, 13. It is decrementing. If you want to pause those operation, you can pause by pressing the 5th key in the matrix keypad. So it is written here, 5th is pause and 6 means stop, 4 means resume. If I press 4, it resumes. The fan is operating. If I press 5, it is stopped. The fan is also stopped. Now if I press 6, it will go into the cooking mode display. So I will again select 1. The power equal to 900 watts, it will be displayed. Now let me set the time as 10 seconds and I will press enter. If I press this RB3 key, you can see the door status equal to open, please close the door. There will be a warning for the user. The time is being paused. I'm now resuming the time. Let it finish. So once the timer becomes 0, it will display a time up alert to the user by turning on the buzzer, and then it will go to the cooking mode display screen. So this is the overall view for micro mode. Now let's move on to the grill mode. So for accessing the grill mode, the matrix keypad number is 2. So let's press the 2 in the matrix keypad, and it will again immediately display the set time screen. The difference between micro mode and the grill mode is after key 1 of the micro mode is pressed, it displays power equal to 900 watt screen to the user. But in this, we don't have such feature. So it displays now the set time screen where we need to set the minutes and seconds for the grill mode to be running. Now let's select the 30 seconds, and if I press hash, it means enter into the next process. And the time display screen appears where the timer is running in a decremented fashion. So if I want to pause those operations, I can press 5 to pause. If I want to resume, I can press 4. If I want to stop and go to the cooking mode display, I can press 6. So it's again going to the cooking mode display. So now I will press 2 again. Set time screen appears. I will set 30 seconds as the value, and I will press enter. The timer starts decrementing till it reaches to 0 seconds. Now if I press this RB3 key, so as long as I am pressing this RB3 key, it alerts the user as door status equal to open, please close the door. So it is running, so the fan is also running. If I pause the operation, the fan will also stop. Now let me resume the time for the grill mode to complete. Ten seconds more. A time up message is alerted to the user that the grill mode is over. So it again goes to the cooking display screen. So this is the process of the grill mode present here. That's all about the grill mode. So now let's move on to the convection mode. To access the convection mode, we need to press key 3 in the matrix keypad. Now I'm pressing the key 3. As soon as I press the key 3, it moves on to the set temperature screen. So we need to set the temperature for the microwave oven to be preheated. So let's select 214 as the temperature to be preheated, and I have specified the temperature. If you want to clear those values, you can clear and you can assign a new value to it. Now I am displaying it as 215 and I am pressing enter. The preheating screen appears and the timer reduces from 180 seconds, that means 3 minutes. So we need 3 minutes to be preheated to 215 degrees Celsius. Now let's wait for the microwave oven to be preheated to that particular temperature value. We can also change this value in the MPLAB XID using the X8 compiler. It will keep on decrementing till it reaches 0 seconds. Since the microwave oven has to be heated till 215 degrees Celsius, we need to preheat the oven for a few minutes. Hence, we are setting a time 3 minutes for preheating. Ten seconds to go. So as soon as the preheating completes, now the microwave oven is set to 215 degrees Celsius. We need to set the time to be running for that particular temperature. I'll press 20 seconds for now and I'll press enter. So the same time display screen will appear where the timer is decrementing and the fan is running. Now it is running at a 215 degrees Celsius. Now if I want to pause, I will pause, and if I want to start, I will start again. If I want to stop, you can press the 6. If the door is open right now, so if the door is open, we will get the alert message. Now let's resume the operation again. Now after the convection mode is over, timer alert will be given to the user and it will again go to the cooking mode display screen. So that's all about the convection mode of cooking. Now let's see the start mode implementation. To go into the start mode, we need to press the key number 4 for it. So we are in the start mode option. The time display screen runs from default 30 seconds. If you want to increase the value in the start mode, we can do so by pressing the key number 4. So we are incremented the current value by 30 seconds to the last value. If you want to still increment by 30 seconds, you can do so by pressing the key number 4. And the other operations are same, like 5 for pause and 6 for stop and 4 for resume. The door is open. Door status will be open and please close the door will be the message which will be alerted to the user. So now let's wait for the time to end. Hence the start mode has ended and it has gone to the cooking mode display screen. Thus we have implemented all those 4 modes and we have seen what is present in all those 4 modes.